things going on. Let me see what was first on our queue of questions. No one's in the queue, but there were people that I didn't have time to get to on Thursday, so I'll do those first. Where are they? Homework help. That was a fun one. Let me see who else had one. Oh, you know what? I did want to do. I wanted to do this. Yeah. This was the question. This was the capacitor question. Yeah, I like this one. This is a fun one. Okay, we're gonna learn a little bit about circuits. Circuits are dope. I like circuits. Okay, cool. All right, it says in the given circuit in the steady state. Steady state, cool. Steady state means that, like, stuff is not changing. Usually, like, current's the same or something. Obtain expressions for the potential drop, the charge, and the energy stored in the capacitor C. Ooh, very cool. Okay. Well, all of these things are in parallel, are they not, with each other? Which I believe things in parallel need to have the same voltage. Right? That's actually a pretty cool question. Also, okay, yeah, key thing to know is that in the steady state, this means like after, steady state means like after a long time. This is like after a long time. And after a long time, there will no longer be any current flowing across this capacitor. At the beginning, when this circuit is first connected and put together, the capacitor has no charge on it. And so what happens is positive charge from this battery has to dump onto this capacitor, like it tries to fill it. And I believe what tries to happen is that this should oh, okay, cool. I like that limit question. Okay, we can do that next, Narowski, since there's no one in the queue. I believe this will become the same voltage as this, because there's gonna be no current. Yeah, so in the steady state, you have zero current here. Right? There's zero current. I is equal to 0. Huh. So, yeah, and they talk a lot about this, like AC and DC circuits. So, for instance, capacitors in AC circuits, in capacitors in DC circuits act as breaks. In AC circuits, they act as shorts, I think. Yeah. In the long term. So I don't think this thing like even contributes in the long term. I want to say that. I want to say that this just becomes the same potential as this. Oh, where can you submit questions? Oh, the website right there, actualofficehours.com. Oh yeah, my bad. Sorry. Let me turn on all the chats. I forgot to turn on the YouTube chat and the TikTok chat. There you go. Yes, exactly. When the PD, I think when the PD power delivery, is that what you're saying? Oh, zero current doesn't mean zero potential difference. Thank you, Big Hamiltonian. Yeah. It would if it was a resistor, right, though, right? If there's zero current across a resistor, there's no potential, there's no drop. I want to say it's the same potential drop, though. PD's potential difference. Yeah. Okay. Yeah, I think the potential has to be the same. So, I mean, I'm tempted to say that the potential drop across C is just equal to V. Yeah. I think you also want to think about it in terms of the potential drop across BE has to be the same as across AF and CD. I agree with that. I agree that this potential drop has to be the same as this, has to be same as this, because all three of these lines are in parallel. I wonder if we want to write, like, Kirchhoff stuff. You think so? I forget how we write, like, can we still write the loop laws the same way? For, Bork says that's wrong. It shows how much I know about circuits. What? All right, one sec. We have a chat is disagreeing with each other, which I like. I love discourse. Let's try to like solve this. Bork's like, that's just wrong.
You done messed up,
Well, Bork, what is correct then? Bork, are you claiming that these three Kirchhoff's rules, but the capacitor? Yeah, okay. So maybe I'm gonna define some stuff. Like, I'm pretty sure we can define the current here. Yeah, let's write out Kirchhoff's. Okay, cool. All right, I'm gonna write some loops. Yeah, can we write some loops? We cool with that? Okay. So in the steady state, also, right? If this is positive, correct me if I'm wrong. I think. How does this build up with charge? Probably 2 volts on the top. But what about these sides? Here's what I'm curious about. So if I have, let's just say a simple circuit like this, okay? Battery and a capacitor, right? This is positive, this is negative. I know this is not technically where charge runs. We can think that this will deposit charge here. This will deposit, I know technically it doesn't deposit positive or negative charge, but for the convention. And then what ends up happening is this matches the potential of this. Right? Because then the potential drop, right? This if you're going, whatever, from Kirchhoff's law, right? So you'd have V battery, right? And then if you're going across from a positive to a negative, I believe that's subtracting, right? And then you'd say minus V capacitor, and then this would be equal to 0. And that makes sense, right? Because from Kirchhoff's law, I need the loop of voltage and a current to be 0. How'd you submit? There's a website right there. On the website? Yeah. Just go to here, go to the website. We already got 3 questions. Great. Good job, guys. You just drag your screenshot in and just hit upload. And it'll come in, and then here's the queue so far. What do we got so far? Great. Physics question. Love that. Invertible matrices. Cool. Great. Solve the differential equation. These are all great questions. You guys are awesome today. Yes, I agree with Q equals CV. And then, yes, energy is 1/2 CV squared. That's correct, shush, for this. But we got to figure out I think we got to figure out the potential drop. There is no current in BE. I agree with that, Devil. Yeah, we talked about that already, right? So steady state after a long time means that this is going to be at the same charge as this, right? So I believe this will have a bunch of positive charges on it, right? This will have a bunch of negative charges. But, okay, it may not be the same voltage as this. Here, let's draw a loop. Let's draw a loop. Draw a loop. Okay. Let's go around this way. Let's just do that. Okay. All right, let me use a different color, sorry. Red loop. Red loop going around this way, right? Okay. So we're going to start with V. Then we're going to minus the voltage of the capacitor, right? Because we're going across from positive to negative. I need to then come up with a current direction for this. Let's call this, for instance, let's call this I3. I'm going to call this I2 or I1. Right, for first, second, and third branch, okay? So then when you come across here, you're going opposite to the conventional direction of current. So that's going to be plus I3-2R. I3 equals I1, though. You're correct from this. Yes. Very good. Manic says, hey, I just want to say thank you for the help last week. I think I bombed the exam. Uh-oh. Well, I hope I could have helped you on it. It's okay if you didn't do too great on the exam the first time. We can help you on the next one. Make sure you get a copy of your exam, by the way, so we can look and see what went wrong. But okay, yes, I'll get to why I3 equals I1 in a second. That's another Kirchhoff law. But from here, you're going against this, so that's going to be plus I3 2R. And then again, you're going across a battery the wrong direction. So that's going to be minus 2V. And then this just has to equal 0. Are we good with the red loop so far? I think so, yeah? Okay. Let's do the pink loop. Let's do the pink one. Let's go this way. I think I'm gonna go this way. Same thing. V minus VC. And then now I'm going against this one. So that's going to be plus I1 times R. And then that's minus V. I click into the website. I'm not really seeing a submit. Oh, no. Well, okay. No. Okay. Big sports. So here, right? The website. Type your username in. Click here to or drag and drop, and then just hit upload. Upload is the button. Or you can click here. You can click this button on your phone, and it'll actually pull up the camera on your device. Okay, do we agree with this? Although I see some issues here. Or maybe not, actually. Okay, one sec. And then also by the juncture law, okay, we know the current coming into a juncture has to equal the sum of the currents going out. So here, this is actually kind of cool. So current in, this shows me that one of them is going to be reversed. It has to be, right? Because look, I have I3 plus I1 coming into juncture E, but because this is steady state and the capacitor is charged, there's no current on this branch BE. So that tells me that I1 plus I3, current in, must equal current out, which is 0. So that tells me I1 is equal to negative I3. You figured it out? Good. Shush. All right. The website, actualofficehours.com. It's right there. This is actually really cool. This may just end up being the same shit then, because watch what happens. All right. So if I say that I1 equals negative I3, and let's just call that then just I. Let's say I1 equals negative I3, which is equal to, I'm gonna just say that I1 is equal to I. Okay. So, yeah, also the link in my bio also works, yeah. Very good. Okay, so from this, I have V minus 2V, so that's negative V. So we have negative V minus VC, and then here I3 is negative I, so then that's minus 2IR is equal to 0. I think this is going to give us the same thing. This is going to give us V minus V, which is 0. And then we have negative VC. And then we have plus IR is equal to 0. Yeah, there's a Q. I1 does not equal negative I3. Why not? So in the steady state Bork, right, at juncture E, there should be no current because the capacitor in steady state acts like an open circuit. I've defined I1 to be the clockwise direction here and the counterclockwise direction here, and the current into a juncture has to equal the current out of the juncture. The current going into that juncture is I1 and I3. The only current that could come out is maybe whatever this I is on arm BE, but that doesn't exist. That's 0. So I believe this is correct. Does this make sense, though? I'm cutting the Q.
You done messed up, AA Ron!
The only way you can cut the Q is if you watch on Twitch and you gain enough channel points to buy. There's a perk called Me First. If you buy that perk, you can skip the Q. Oh, you're a sign error? Okay, all good. Shush, if you say it more times, it doesn't become true. Doesn't work like that. Okay. So let's see. I think from this, right, I'm going to get that VC is equal to, what is that? Negative VC minus 2IR, right, from this. If I just move that over. And then from this, I get that VC is equal to IR. Or sorry, VC is equal to negative V. Sorry, minus 2IR. And from here, I get VC is just equal to IR. Well, I mean, the fuck does that really tell me? Oh, wait. It's from Putnam. I fucking hate Putnam.
You done messed up, Aaron.
Okay, wait. We can plug this in. I think I see something here, right? VC. Here, let's combine these two things. I think this does something. Watch. So from this, you get that if I were to plug whatever VC in for here, I get VC is equal to negative V minus 2 VC. So 3 VC is equal to negative V. So that tells me VC is equal to negative V over 3. Cool. Mistake, the minus V. Will says, yo, I watched some of your videos and they're really good. Thanks, Twin. I can finally do my homework now. Fuck yeah. Appreciate that, Will. Okay, where did I mess up? Am I losing my signs here? Bork. I make mistakes sometimes.
Obviously, don't go and do that.
You don't want to do that. Or let's see. How long is the queue? The queue's now 8 questions. Y'all jumped on the questions. Let me make sure we didn't make any mistakes here first. Okay, wait. V minus 2V is negative V. Negative VC, that's fine. Plus I32R. In the pink box, what is the change? So here's what I'm doing. I'm taking this original question, Bork, right? And then instead of writing IR, I'm writing VC. So then I get that VC is equal to negative V minus, and instead of 2IR, I'm writing 2VC. So now when I move that over, that's 3VC is equal to negative V, which then tells me that VC is equal to negative V over 3. Which I think that should make sense. It's kind of weird actually that it has a different voltage. But I guess that's just the nature of what it is. How do I get VC equals IR? I got that from here. So from the pink loop, right? We had V minus VC and then plus I1R because we're going across this resistor. And then minus V is equal to 0. V minus V cancels. And so then I get VC is equal to IR. Or I1R, but we're calling I1 just equal to I. Okay, cool. I think we're good. I think this is good. Thank you, whoever told me just like fucking write out Kirchhoff's laws. That sometimes does just help. Okay, so then the charge. The charge is easy. Right. All we really needed is this. This was the hardest part. So charge. You have Q is equal to VC times C. Just trying to get all my V's correct, right? So that's equal to negative CV over 3, which really charge is positive. It's just whatever, like, convention is. Cool. Right? Good with that? Yeah. And then the energy stored in the capacitor. Again, this is easy. Kirchhoff. I never know which one to say. So energy is equal to 1/2 CV squared. I'm going to say, like, CV. Or CV, but then technically it's VC squared. Okay, so then that is equal to 1/2 C, and then that's V over 3 squared. And so that should give us 1/18 CV squared. And I think I'm allowed to put it in that way. Cool. Yeah. You could also say that as well. And actually, here's the cool thing. I threw this into ChatGPT as well, just in case. And Bada bing, bada boom. Look at that. V over 3. CV over 3. CV squared of 18. We did it. Good job, guys.
That's
Awesome. Cool question. Love the circuits. That was from Pi. That was physics, what we were doing right there. Again, if you're watching, where to submit questions, actualofficehours.com. That's the website for it. Also, while you're there, go join our Discord. Our Discord's dope. And so what you'll see here is that inside our Discord, we do a lot of cool stuff. We give out gift cards. We motivate kids to like do well in math, science, whatever, life. But also every time we do a question, it gets put into our Discord here, and then I'll post the solution as well. So it's always there. Fucking hate capacitors, yeah. Okay. Well, I think capacitors okay. Inductors like suck. Alright, let's go see what's on the queue. Alright, first one's from M here. Wow, looks like a lot of fun. Okay. I might do like just one of these, M, just for time's sake. This looks like a kinematics question to start things off. Okay, physics student shoots a basketball from the ground at a hoop which is 2 meters above her release. The shot was at a velocity of 10 with an angle of 80 degrees to the ground. Determine the vertical velocity of the ball when it is at level with the net. You should get 2 answers. Yeah, the reason why you get 2 answers, right, is there's 2 places this happens. ChatGPT is free, but learning is not. I mean, well, technically the learning here is free, but what I meant to say is that, like, ChatGPT is great for getting answers, and it is great for learning, provided you use it to learn, not to just copy shit. And I don't know, sometimes people like a human to explain things versus a clanker. So yeah, there are 2 different periods here where the ball will end up being level with the net, right? There's right before it, or I guess this is technically where it hits the net, right? Otherwise, the person didn't score. Okay, I think it's technically this, yeah. All right, this is a parabola. Okay, they want vertical. You dropped the C word. Don't come after me in the future, chat. Don't do it. Vertical velocity. All right, so that's Vy is what we're looking for. And more so, we're looking for Vy when y is equal to 4. Okay? This is helpful because now I know kind of what I'm looking for, what I'm given, right? I know that my y final is equal to 4, and then I have a bunch of other initial shit so we can like use kinematics. Well, so technically yeah, so Jeff, whether y is equal to 2 or 4 depends on what we define as 0. I'm defining the ground as 0, which means that the initial starting height of this throw will technically be 2. You're correct. Delta y would be equal to 2. Yeah. This is 18 years old is like a senior in college, or senior in high school or undergrad in college. Sorry, that's what I'm gonna say. Okay, so the way to figure this out is we know that Vy. This is actually really cool. You can use. Let me pull up all the Suvat equations. I'll show you which one I want to use. I think I like this format of them. Yeah, let's use this. So notice Vy is like Vy final. This is like final. You define the ground as 67? No. Oh no, don't do that. You make me sad. So this is final velocity. I know what my y position is. And I don't have anything in terms of time, right? So I'm going to look at my equations here and be like, well, which one doesn't have time? Bingo, it's this one.
My man.
Do you think it's harder, UK or US? I think they're harder in different ways. It's like asking, I don't know, who's a better athlete, right? Like a marathon runner or like a long distance swimmer. Depends like how you're measuring their athletic abilities. We're gonna use this one. Okay, so Vy final squared is equal to Vy initial squared plus 2 times the acceleration, which in the y direction, the acceleration of anything is equal to negative 9.8. So Ay is equal to negative 9.8. And then that's also delta y. And delta y is equal to y final minus y initial, which in this case, y final is equal to 4, and y initial was equal to 2. So yeah, this is where Jeff, the two just comes in handy anyways. All right, so y final squared, that's what we're going to solve for. Is equal to y initial. Now this is shot at an angle, right? More so it's shot at an angle of, let me get a different color. Shot at an angle of 80 degrees. So Vy is going to be the component, which is going to be equal to 10 sine of 80 degrees. Yeah, A levels can be pretty brutal for sure. But so can some AP questions, honestly. So anyways, that is going to come over here. So that's going to be 10 sine 80 degrees squared plus 2. AY is now negative 9.8. And then we got another 2 in there. So we're going to get 2 different answers, which is actually kind of cool. They're going to be positive negatives of each other. Black Pill. What's up? Did you see the Terra Chad has arrived, Black Pill, and he's looking to frame Mog, the ASU frat leader, as revenge? I heard brutal. All right. A-level physics, yeah, that could be tough. AP physics is also pretty hard in the US. It's I think the average score is like a 50% on it. All right, let's pull up the calculator. Let's do some numbers. So, 10 sine 80 squared. And then that's going to be minus 4 times 9.8. And that's going to equal 57.78. So then you square root that. And that's going to get us plus or minus 7.6. Because when you square root, you have to have the positive and the negative one. And that should make sense. Okay? Why you're going to get 2 answers. Because one of the points when it's at the height of the net is when it's going up. And then the other point is when it's going down. And so that's why you get equal and opposite versions of it. Yeah. Number 2 ranked Chad needs to hair transplant Max to Mog. ASU frat leader ranked number 1 global leaderboard Chad varies. Oh, man. Yes, they are different vectors. Yeah. Using your answers to A, determine the times of flight from release to the 2-meter vertical displacement of the basket. Oh, okay. So that we can then use, what is it? This question. With this equation, sorry. We're going to use this one. Let's use this. Let's like move her in. There we go. So there, delta x, or delta y in this case, will be 2. And then that's going to equal to v initial which is in the y direction, so that's 10 sine of 80 degrees. And then times time. And then plus 1/2 a t squared, which a again is negative 9.8, so it's really minus 4.9 t squared. Yeah. Cool. All right, and then we just got to solve for this. This is a quadratic. Which is unfortunate. Yeah, not the easiest thing to solve. So this is technically a quadratic. Because you have t and you have t squared and you have some other shit here. It like fucks it up. So this is quadratic. A couple ways to do this. You could use a quadratic formula, which I don't really want to. The other way is to plug it into the calculator. Yeah, you guys know what's up. Yeah, you can literally just plug this in. So that's going to be negative 4.9 t squared, right? We're going to use x squared. And then we're going to say plus 10 sine of 80 degrees times t. T in this case is x. And then minus 2. Trace it. See what we get. There you go. And then we can just do second calc. The zeros. I don't know, yeah. Make the left bound 0. Make the right bound for the first one, like right there. So there's your first one. I'll just put that in here. There's your first 0. And then if you want the next one, let's put the left bound over here. Right bound way over here. And there you go. Those are your 2 times. Okay, so 0.229 and 1.78. These are the 2 times. T equals that one and that one. Okay, when solving projectiles, you often get 2 possible times for solutions. Sometimes a time will be negative and can be rejected. Other times, both will be positive and possible. Explain why both times make sense in the context of the given information used. Which time will you ultimately choose and why? Use the diagram to label where the 2 times. Yeah, cool. All right, well, yes. So you want to... There are 2 times at which the ball is at the height of the basket, but you want the time at which the horizontal displacement is the same as that of the basket, which in this case is the second one, right? Because the ball's gonna have to go up past the plane of the hoop, and then it'll come back down and hit the hoop. So just say you use the second one. You could write some other English words for the rest of it, but all good. Cool. All right. Good question. Great, M. Let me know in the chat if you wanted me to explain anything else there that didn't make sense. I'll help you out. Otherwise, I'm going to keep moving forward because we do got a lot of cool questions I got asked today. There's our previous ChatGPT stuff. We don't need that. Where is... I'm cheating on my exam right now. Dude, who posted that? What? Don't do that. You cheat, you're just cheating yourself, dog. Can we skip to 7? Unfortunately not. No. If you want to donate to the nonprofit, I will let you skip in that case. Yeah. Everything we do here is free, but we do take like donations to help pay for like the electricity and stuff. Number 2 ranked Chad cannot frame Mog and spike ASU frat leader's cortisol, causing atrophy and make him descend. Yeah, you can definitely donate on TikTok. Yeah. You can like send like bits or whatever the fuck. I don't know. Just send something that's at least like $1. All right. Let's see. Next one is on matrices. Jeff's gonna be so happy.
That's dope.
We're doing math again. We're doing math, Jeff. Jeff's so happy when we do math. Routine corner, yeah. The bonflation, as we call it, right? Oh, there you go. You sent the hand heart. Nice. That's 39 cents. Now keep in mind, Shush, if I do your question first, and it looks like something that's gonna take a lot of time, I might still skip it though, just in the interest of everyone else that we're trying to help. But thank you, Shush. Yeah, I'll take it. I will take a look at. That's $5. It says it's 81 cents for me, but it's okay. I'll take a look at it. I'll take a look at yours next. I appreciate you donating. Okay. Maybe it's like $5 Canadian. Okay, factor each invertible matrix as a product of elementary matrices. Oh, interesting. What are elementary matrices, by the way? Is that just like 1 0 0 1? Like is this an elementary matrix? Maybe it's because TikTok finesses. They probably do. I am Pi. Thanks for solving that. Question was for my last year's board exam. Graduate high school and hard school. Most are going to be able to solve it. Okay. Good luck on your thing.
Oh, yeah.
You had to look it up? Yeah, what the fuck's going on here? Elementary matrix. Okay, wait. There are 3 types of elementary matrices. Oh, which correspond to row ops. Okay. Row switching can be switched with another row. Okay. I see. Yes. So 0 1 1 0 exchanges row 1 with row 2. I agree with that. Okay, cool. Row multiplying would just be a diagonal matrix. That's cool. Row addition. How does that work? Oh, congrats, dude.
Good job.
How are you able to get your bachelor's in 3 years? Did you come in with a lot of credits? Maybe let's do how we would row reduce this, and then I think that should tell me what the different operations are, right? I'm just gonna do the first one. The second one, you know, by inspection's the same thing. So in order to get to, we want to get this to, it's called a scam, depending what you do. I think it's a scam if you're getting a useless degree and you're not developing your life personally at college. Yes, then I would say it's a scam. Oh, nice. Yeah, credits. Yeah, high school credits will help you out. So we want to turn that into this somehow. This is the identity matrix. Yeah, online credits, those can super help too. Yeah.
Oh, yeah.
There's a lot of really cool websites actually you can use to just get college credit for stuff for free actually online. You just gotta like take courses and stuff. Someone sent me the website at some point. I think it's called CLEP. Is it called CLEP? C-L-E-P? Is that what it is? CLEP exam? You're going to education after college. Sick.
My man.
We need more people in education. All right. I think the first thing I want to do is let's like add row 1 to row 2, right? So I'm going to say that like R1 plus R2 becomes R2. So that'll give me a new matrix. And then I'm going to write out like what the matrix would be. So if I add this row to this row, then I get 2, 4, 0, 3. Yeah? And then I think my next thing to do is to just divide this one by 3. So I'm going to say 1/3 times R2 goes to R2. That would give me 2, 4, 0, 1, right? Then I could do -4 R2 plus R1. And that would give me, so -4 of these added to this would give me 2, 0, 0, 1. And then finally what we want to do is 1/2 of row 1 is going to go to row 1. Cool. Okay, so this is how we do this. So when I do these operations, and things act on it from closest to furthest, So let's call this like operation 1, operation 2, operation 3, operation 4. What's really happening, and let's call this vector, let's call this A, and we're trying to turn it into I. So we're going to first do some sort of elementary row operation, which can be represented as a matrix, E1, onto A to get me to this step, okay? So if we wanted to write out what's happening here, at this point, you have E1 times A is equal to this, right? Here, I can like, let's copy it. No, I want to do it this way. So this equals E1A. Okay. Then I act E2 on E1A. So this is going to be E2 E1A. Then I'm going to act whatever E3 is. Onto E2 E1A. And so that's going to be E3 E2 E1A. And then finally I can act E4 onto this whole thing. Yeah, right? Because then this gets me my 1, 0, 0, 1. And that's going to be equal to E4, E3, E2, E1 times A. Okay, cool. And that's all equal to now the identity matrix, which is what this is. Let me move this over. Yeah, okay. Okay, so I have to kind of think about like how these work. I teach physics at UCLA, yeah. So I have this E1, E4, E3, E2, E1A is equal to the identity matrix, but I want to write A as a product of elementary matrices. Okay, so I think A now needs to be written as, so if we want to get A by itself, this is kind of cool. You're going to act each of these on the other side. So watch what I'll do. You should teach physics at ASU. So I can go find the ASU frat guy. So if I act E4 on this will cancel out. Or if I act E4 inverse on it. Right? This is actually pretty cool. So this will go away. And then I would be left with this. So this would be E4 inverse times the identity matrix. So then I would need to act E3 inverse onto it. And then that would give me E3, E4. Okay, so, and then I'm not going to show all the other steps, but then whatever. Ditto. You end up getting that A is equal to E1 inverse, E2 inverse, E3 inverse, E4 inverse times the identity matrix. Did you know that ASU frat leader is majoring in aerospace? He probably is. He's probably a smart guy. Not everyone who looks like that has to be absolutely like dumb.
Not good.
I mean, I don't know. Okay. So I think we just need to identify like what all these different operations are, right? So I think I can think of some simple ones here, right? So E4 was taking whatever it was and then just multiplying it by a half, and only to the first row, right? So let me think how that works. Yeah, okay. So E4 was just 1/2 on row 1. Which, okay, let's think about as a matrix how that is. How do you do that? How do you only multiply row 1 by 1/2? If I want to multiply the whole matrix by 1/2, it would be this, right? How do I get it to just do the first row? Let's see. Each element in a row can be multiplied by non-zero is known as a scaling row. K row, okay. So row multiplication. Oh, this looks like so icky. Multiplies all elements on row I by m, where m is a non-zero scalar. The corresponding matrix is a diagonal matrix with the diagonals entries 1 everywhere except the ith position where it is m. Okay, so if we're multiplying row 1, then the ith diagonal has to be 1/2. Yes, exactly. Right. So I think it's this. Yeah? 1/2, 0, 0, 1. Is the, right? But then we want the inverse. Yeah? Right? Because and think about this. Let's say, for instance, you had this acting on, like, A, B, C, D, right? If you did this, right? So this times this only multiplies the 1/2 by A, right? So you get 1/2 A. This times this just gets you 1/2 B. And then coming down to here, yeah, 0. So this becomes C, and then this times this is D. Okay, cool. So this makes sense. Wow, that's super cool. Okay, so that's what E4 was. Okay, so what's E4 inverse then? I believe the so E4 inverse is equal to 1 over the determinant of E4. And then you switch some things. I think you switch these, right? Is that 1 and 1/2? And then wait, I gotta remember yeah, what's it? Inverting a 2x2 matrix. This is it. That's cute. Okay. So yeah, you do switch these, and then you make these negative, but these are 0. So I don't care. Okay, so it's that. And then the determinant of E4 is this minus this, but that's 1/2. So 1 over 1/2 is 2. What is GPA? Grade point average. Okay, cool. And 1 over 1/2 is 2, so this is equal to 2001. Okay, we found E4. Great. We found E4 inverse. Now we just gotta go back and find all the other ones.
You're not that guy, pal. Trust me. You're not that guy.
Are there any other cool ones? This one was cool, right? 1/3 R2. I can do that one real easy, right? So E2 was 1/3 R2. So from before, that's 1, 0, 0, 1/3. So E2 inverse is going to equal to 1 over the determinant of that. So that's 1 over 1/3. And then 1/3, 1, 0, 0. And so that's 3. So that's going to be 1, 3, right? I got the hang of this. Okay. I think I got this. Nice. Yep. Cool. All right, we got E2 inverse. I think the row adding ones are going to mess with me. Oh, man. Okay. Adds row J multiplied by a scalar M to row I. This corresponding matrix is an identity matrix, but with M in the IJ position. Okay, wait, sorry. Adds row J. I gotta write this. I gotta see this. All right, this is. Let's do this. What is this? E1 is R1 plus R2. And I think that was equaling to R2, right? Okay, that's a row addition. Here, I'm going to also put the... This was cool. I've been learning a lot. Have you ever seen this before, Jeff, actually? Have you seen matrix operations? The inverse will be the same matrix with minus m. Interesting. Oh, because the off diagonals don't change. Well, they become minus, right? Yes. So an identity matrix, which is cool, right? So the identity matrix would be this, right? But then if you're adding row J to row I, so in this case, we're adding J is equal to 1. So row J is being multiplied by a scalar of 1. And it's being added to row I, which in this case, I is equal to 2. So M needs to be in the IJ position. So in this case, we needed M equals 1 in the 2, 1 position. Yeah, it's pretty cool, isn't it, Jeff? I think it's cool. All right, so second row, first column, so that's going to be equal to 1. So that tells me that E1 is going to be equal to 1, 0, 1, 1. And then Hamiltonian says if I want to invert this, right, the determinant is just 1. Beautiful. And then 1 switching with 1 is just 1. And so, but these do change from this. They become negative. So dope. Okay. So E1 inverse is just equal to 1, 0, negative 1, 1. Nice. All right, last one. We almost got this, guys. E2. No, E3. What? Come back down here. There we go. Okay. So E3 so in this case M is equal to negative 4. And we're adding row 2. So J is equal to 2. And we're adding it to row 1. So I equals 1. So then M equals negative 4 in the 1, 2 position. Beautiful. So E3 is equal to 1, 1. First row, second column. 0, negative 4. Beautiful. What's up, Rex? Good to see you, Rex. So then E3 inverse is going to be equal to... That doesn't change, right? So I think it's just going to be 1, 4, 0, 1. Yeah? Nice. Okay, cool. So putting it all together. So all together, we had this. Good evening, Fanatic. What's going on, dude? What is going on? Oh, it is not just pasting where I need it to. Okay. Cool. Okay, so E1 inverse was this. So we had this. E2 inverse was this one. E3 inverse was this one. And then E4 inverse is, where was it? Where is she at? There she is. Nice. Cool. I think that's correct. Looks good to me. Actually, we can check chat real quick.
Well done.
Alright, what does ChatGPT say? Let me see. 1 0 0 negative 1 1 0 0 3 1 4 0 0. Yep, nice. Cool, we did it.
Oh, yeah.
Sick. That was cool. I've never done that. I've never decomposed a matrix into identity. Sorry, what was it saying? A product of elementary matrices. Shush says me next. Yes. Okay, Shush. I will check you out. That was Pierce the Veil. Definitely feel like my veil got pierced. My veil of knowledge over linear algebra.
Surprise, motherfucker.
Yeah, it was a pretty cool question. Yeah, this was pretty fun. Never done it before. The other fun thing, Pierce the Veil, if you're watching, is that every time we upload a question, we upload the solution to it. We also upload the the timestamp and the link to where in the live stream it was taking place, so you can go watch it again. That was a fun one, though. Next, a product of middle school matrices. Well, Shush said we were gonna do theirs next, but Shush, which one are you, Shush? Who are you? Hottie? Is Hottie your name? Is this it? Shush says this is a Putnam question. Okay, cool. Is this really tough? I don't know if this looks that tough, does it, Hottie? Where A and B have to be positive integers? That kind of what we're saying, yeah? Okay. I think I just multiply each side by AB, basically, right? So, yeah, let's do it. Alright, so... Is this just partial fractions decomposition? But, like, with numbers? Yeah, we just need the factors of 2018, right? Is equal to 3 over 2018. So if you multiply both sides by AB... This isn't that bad, right? So if I multiply this by this, then I get... so AB over A plus AB over B is equal to 3AB over 2018. This will cancel... yeah, okay, sure. Cancel. I think this is kind of what I want, right? Then I get... this question is a wolf dressed in... Is it really tough? B plus A is equal to 3AB over 2018. Or actually, okay, let me do this a different way. Let me multiply this by maybe multiply this, sorry, by AB over AB. I think this is what I wanted to do. No, I'm gonna multiply this one by B over B, multiply this one by A over A. So then I get B over B plus A over AB is equal to 3 over 2018. So then I need what numbers add up to 3 but multiply to 2018? Well, how does that work? Wait, what? The fuck? It's all possible combinations for A and B. But wait, they have to be positive. You said they had to be positive. Oh, I see. I see what you're saying. Yeah. Because then this could be a multiple. Let's say like times x, right? Oh, I see. So a plus b is equal to like 3x. And then a times b is equal to 2018x. Well, my intuition says this is not solvable. Because I have 2 equations and 2 unknowns. I have 3 unknowns, right? I don't know a, I don't know b, and I also don't know x. Or maybe I do. Wait, I'm sorry. A plus b equals to 3. A times b is equal to 2018. And then someone showed me a glimpse of an equivalence between this and factoring a quadratic. Oh, is this what's that dude's theorem? No shit, Sherlock. It's a Putnam question. Well, okay. Yeah, is it rational roots? Right? Rational root theorem, maybe? Oh. Dun, 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 dun. Because I think, okay, you can think of it this way, right? So if you had x squared plus a plus bx plus a times b, right, equal to 0, this should factor into x plus a, x plus b, right? Ooh, okay. Oh, bingo. Yeah, okay. Yeah, okay. I like Fanatic's idea here. Yep, this is cool. Right, but we already said that a plus b was equal to 3. Okay, so x squared plus 3x plus 2018 is equal to 0. Yeah, because I was thinking about just like the what is it, the factoring rule. Right? Yeah, whatever, like, if you had, like, for instance, like, x squared plus 5x plus 6 is equal to 0, you're always like, okay, well, what multiplies to 6, and then what, like, adds to 5? And then, in that case, you get a equals 2, b equals 3, and then it's a plus 2, b plus 3, right? The trick looks fancy, right, Dreamer Dawn? I think this is cool. No. It's... So, I think I agree. I agree it looks... You don't fully understand it. Well, I think I understand this, right? I understand, like, for any perfect square trinomial, right? That follows this rule, right? These two things add up to this. These two things multiply to this. And then you get these as factors. So if we just solve this, shouldn't we get something? And then this should give us 2 points. Wait. Adds up to 218. Wait, this will never equal 0 though. Wait, what?
Surprise, motherfucker. You messed up, Aaron.
Shouldn't the sign of the products be negative? I think so. Yeah, wait, because how is this going to work? Oh, sorry, we're not going to solve as equal to 0. Sorry, what am I saying? Sorry, no. Sorry, this just doesn't equal to 0. Sorry, no. Sorry, this is what I meant to say. Yeah, sorry. This is a plus b. No, wait, sorry. X plus a. X plus b. That's what I want to say. Okay. No equal to 0. Yeah. A and B are their roots. I see what we're saying. So negative A, negative B are the roots. Yes, I agree. This should be minus 3x. Yeah, no, but here's what you do. Here's what you do. So, yeah, the factors. So the factors are x plus A, x plus B. But then the roots would be x equals negative A, x equals negative B. So then let's substitute this for negative A, negative B, right? Then you would have x squared minus 3x plus 2018 is equal to 0. And that's for like x minus A, x minus B. This I can solve for sure. What are you doing? Shush. 3AB minus 2018 B minus 2018 A? I don't even know where that's coming from. Shush is just writing a lot of things in chat, but I don't get what's going on. Sorry, I don't follow. One sec. Yeah, let's solve this. I think I can solve this. I think I can solve that for x, right? And then that should give me another expression for what A and B are, right? This is equal to 0. Okay, so what are the factors of 2018 that add up to negative 3? Factor pairs of 2018. Any fun ones? 2018 though, 2018. That's 92. Fuck it. We'll just write them out. Okay. Or actually, let me just use a calculator to solve this. Do we get anything nice? Oh, you don't get anything nice. It actually doesn't work. They're also not real. Ooh. But it could be 3n and 18n. Or 2018n, you mean? Oh. Oof. Okay. I'm gonna punt on this one just so I can help other people out. I agree. This is a cool question, shush, but like I'm not gonna figure it out in the next like 5-10 minutes. I want to make sure I help out other people. But I will put it in our Discord if people want to like have fun with it. Math competition, they're cool. I appreciate like seeing the techniques. But if I can't figure it out within at least 10-20 minutes, then I gotta move forward. Unless we had nothing else to do, but the queue is already like 8 questions. You love to understand. Okay, I would love for someone to explain it then. So here, I'm gonna put it in the Discord. It's here. It's in this channel. I'm gonna mark it as like unsolved. I'm gonna say math gods. Cool. Well, Shoosh, if you want, go join our Discord, and there's a channel here called Homework Help where all the questions get posted. And so there's a thread here that I tagged. There's some really smart math people in my server that they might be able to chime in and talk about it. But cool. Otherwise, I had fun. I learned a little bit. All right, let's see this one. Differential equations. Yeah. Cool. Given that y equals 4 at x equals pi over 6, solve the differential equation, giving your answer in the form y squared is equal to g of x. Ooh. Is this like partial fractions decomposition? No. What am I thinking about? Integrating factors? Sometimes something that happens. Okay, well, maybe this is separable, actually. That's like the first thing you can always try to check. Can you put the variables on different sides? So let's like try to separate. Separate by variable. Differential equations, you learn a lot of different techniques, and it's about identifying patterns. Like saying, oh, this looks like one of these things that I know, and then applying that technique, to solve that pattern of problem. So, what if something's homogeneous? That's beautiful. If it's like, and it's linear, that's great. This is non-linear because you have like cosine squareds happening and shit, and also the things are mixed up. So the next thing is to try to separate it by variable. So anything with x's, I'm gonna put on the right. Anything with y's, I'm gonna put on the left. So that's going to be y dy is equal to 3 sine of 2x over cosine 2x, cosine 2x. That's cosine squared 2x, right? If we divide that over, and then we multiply this, and then this is dx. Okay, so this actually isn't too bad. Because this is going to be... Or actually, okay. I'm gonna leave this as cosine squared 2x. I'm gonna show you why I'm gonna do that. I think I can do u sub then, right? Yeah, and then we're just gonna integrate both sides. Yeah. Yeah, actually, no, you're right. Let's do secant tan. I like that. I like that better. I like that better. It would come out to be the same thing. Yeah, that's why I wrote it out originally as cosine, because I want to identify that this right here is tangent, right? This is tangent. And then this thing must be secant, right? So then you have y dy is equal to 3. And then that's going to be tangent of 2x, secant of 2x. Dx. And then now we can integrate. So let's integrate both sides. This is easy. This just becomes y squared over 2 plus c. And then this is equal to 3 integral tangent 2x sec. So derivative of secant is secant tan. So the integral of secant tan is just secant. Yeah? Yeah, right. So ddx of secant of x, sexy, is secant x tangent of x. So if you look at this, and then the 2 part is like, it's like an inverse chain rule. So instead of multiplying by 2, you divide by 2. So this is going to be 3 times... What's up, Ethan? This is 1/2, and then this is going to be secant 2x. Very cool. And then it's plus c. This is differential equations. So,
hey, like, is this involving integrals? Integrals?
Yeah, it's about integrals. But, I mean, well, there are integrals involved.
But, like, how do integrals work? Like, I honestly don't understand it. And why is plus c always, like, the most necessary thing, even though people forget it? Like, what?
It's only if it's indefinite. It's only if you don't have bounds on it, it's indefinite. It has to do with how an integral is technically an antiderivative. And there are a bunch of different antiderivatives for a single derivative if there's a plus c on it.
Wow, alright then. But to be honest, like, how's it going?
Oh, good. Yeah, we had a lot of questions today. We opened up with a bunch.
Bro, that they go. I have my mock quiz on Friday, you know.
Okay, cool. Do you have any practice questions you want to go over? Yeah, you can totally submit stuff.
I mean,
okay.
To be honest, like, I'll post it in the queue. Yeah, I'll post it.
Yeah, post it. It is interesting to do this because the u sub sine cosine because the answer is not the same. Is it not? I think it would be. So if we did sine cosine, wouldn't that be just 1 over u squared du? Which would then become negative 1 over u, but then, like, whatever, the integral of cosine is negative sine, so that the minus pops out again. I think you end up getting 1 over cosine again, which is then secant. I think you get the same. Yeah, no, you're good. So this is, we need to plug this in to figure shit out. So this is 16 is equal to 3 secant of 2 pi over 6 plus c. So that's, secant is 1 over cosine of pi over 3. Cosine of pi over 3 is 1/2. So 1 over that is 2. Okay, so 16 is equal to 3 times 2 plus c. So c equals 10. Nice. Okay. Oh, so I think we got it. Y is greater than or equal to 0. Sure. X is between negative pi over 4 and pi over 4. I don't know how that matters, but I'm just going to say that y squared is equal to 3 secant of 2x plus 10. I think this is going to be it. Nice. Yes, cool. All right. I think it was good to me. I think the reason maybe they defined negative pi over 4 to pi over 4 is...
Well done.
I get tired too, dude. It's all good, Fanatic. All good, brother. How's your coding thing going? I like seeing your updates on TikTok. They're fun. This was Yaraje. Oh, that's for the... Yes, because 1 over secant... Yes, right. You can't divide by 0. I got you. Totally got you. Okay, nice, Yaraje. Ayums?
Hold on. Where's the link? Got for the Q thing.
It's always here. There you go. What's up, Sam?
The exclamation point submit.
Yeah, it's right there. The link. The link for the website's right there.
All right, let me send it in.
Sam, how's college going, dude? When are you transferring? Next quarter? Have you already transferred? Time goes by so quickly. I had some, what is it? Some girl I used to kind of like see on Instagram and stuff. And I remember we went to a psychic at one point, and she was in the middle of a divorce, and the psychic told her that like she couldn't get married for another 7 years. And I don't know, I think I saw her like on Valentine's Day, she posted another picture of like just like some dude's feet. And I was like, oh, is this like your sneaky link or like your boyfriend? She's like, oh, it's my boyfriend. I'm like, cool, when are you gonna like tell the world about him? And she's like, oh, probably when we get engaged or married. I was like, oh, so in like 7 years? And she says, no, what? We went and saw the psychic back in like 2024. I was like, oh, fuck. Oh, yeah, so, okay, 5 years. So funny. Time just goes by really, really quickly. Spring semester starting Tuesday. Next fall transfer. Nice.
Good job.
Wait, have you not even been at school? You mean spring quarter? I think all of UC is on a quarter system, no? Correct me if I'm wrong. Because wait, it's like almost March. Mid-Feb. Oh, you're still at SMC. Oh, that's right. Yes, SMC is weird. You're right. They do have like a winter semester, right? Which is like 6 weeks and it's like super fast. Did you do any winter courses? Yes. Okay, there you go. I remember. Yeah, SMC is interesting with how they do it. Yeah. It's a good school though, honestly. It's a great path for getting into any of the top UCLA. I have so many friends that did that path, and honestly, it's a lot fucking cheaper. It's smarter too. Yeah, just ethnic studies. You're gonna do underwater, non-binary basket weaving. Completely free. Wow. I didn't know it was completely free. Hell yeah, dude. I almost taught at SMC. I had an interview way back in the day, and like, I got so frustrated. They wanted me to teach over Zoom. I was like, I don't want to do this. So I got kind of frustrated during the interview. But now I teach at UCLA, so like whatever. It's all good. What are we doing right now? Show that this is irrotational. I think if we remember, irrotational means the curl's equal to 0. Right? So let's just build it out. So this is I, J, this is K, this is DDX, DDY, DDZ, and then this is U1, U2, U3. Or you could call it UX, I guess. Whatever. Okay, cool. So, doing the T method. We've done this a couple times. I like this method. You'd love to operate the vector druid. They're cool. Yeah, Nabla, you mean? Nabla's not that crazy, man. It's just about taking derivatives in a bunch of different directions all at once and like how that relates. Civil rights stuff. Oh, that's a hot topic these days. There's a lot of weird stuff with they're trying to like weaponize the Civil Rights Act to like do racist things. It's kind of funny. All in the name of being anti-racist. I don't know. I saw somewhere that Harvard was getting sued for their admissions process because apparently they really heavily discriminate against Asians or something. Which I understand because, you know, if you're everyone, the population of China is much larger than the population of like the US, and they all want to go to Harvard. And they can all get perfect scores on their standardized tests for a multitude of reasons. So I understand eventually just to like enforce or to encourage some sort of like diverse cultural student body, you might start like restricting some people from getting in. It kind of sucks, but I mean, merit isn't everything, I will say. If everything was just like strictly merit, then I don't know, you'd have like some really shitty teachers. I mean, I am in no way like the smartest person in terms of math or science. I don't have the best test scores. I don't have a perfect SAT, but I think I can teach a lot better than most of those people that do have perfect scores. So, and that comes from a variety of backgrounds that I experienced. What is the meaning of cross product? Cross product is, it's finding the curl. So it's finding in a sea of like a vector field, is there any sort of like curvature? Like, so gradient figures out like it's pointing to like where the highest or the lowest spot is, right? In terms of a value. So, right, so this is called gradient, right? Gradient points towards the highest thing. Div.A measures the amount of like sink or source. So it measures like how much of the field is either coming from or going towards a certain point. And then curl of A is measuring how much of the vector field is like rotating around a circular point, rotating around a single point. Yeah, that's kind of how I think about it. So that's that, and then this is du3 dx. Did I do this one? This looks familiar to me. It's familiar, sorry. dz. I think we've done a similar question, but then this is technically minus. Right, the middle one's always negative. And then it's du2 dx minus du1 dy. Yeah. Alright, so, and then this right here is u1. This right here is u2. Or all of this, I guess, sorry. That is all u2. And this is all u3. So du3 dy, that's cool. So that's going to be, derivative of all this with respect to y is negative 2z sine y. And then that's plus 2yx. And then this du2 dz is going to be negative 2z sine y. And then that's going to be 2xy plus 2xy. And look at that. This minus this minus this equals 0.
That's dope.
Yes. Yeah. Yeah, the dot product and the cross product, they do. Yeah. If you want to think about the dot product, right? So the dot product is have the operator act on every coordinate, right? And then sum it all up. So what you're doing is like you're summing up what all the slopes are in each direction. Like, because you're doing ddx, ddy, ddz to the x, to the y, to the z component. So you're seeing like in that direction, how much is it changing? And then you're adding up all those changes. And so that'll tell you if that's positive, that says, oh, everything is kind of moving away from that point, is like increasing. And if it's negative, it's like everything is decreasing towards that point. That's how the sink or source thing works. I'm not sure exactly how cross product looks in terms of curling things. It is very related. And then of course gradient makes sense. Okay, so that one's 0, which is good. du3 dx. That's just y squared. And du1 dz is just y squared. Great. Also equal to 0. I'm gonna assume this is just also equal to 0. Cool. Let's just assume it is. Okay, fine. Find the corresponding potential function. Oh, this is cool, actually. Okay. So for a potential function, okay, if that is... So I think potential function means that gradient of, let's say, phi is equal to mu. And this comes in physics. This is seen a lot, where you have grad U is equal to F, right? You can see that. So, for instance, in simple kinematics, potential energy in, let's say, the gravitational sense is just mgx, right? Or mgy, right? And so if you do the gradient of that, the only thing that survives is ddy is equal to F. And then look at this. You see how this cancels? ddy of mgy is just mg, and that's in the y direction, and that's why the force is mg in the y direction. Yeah. This comes up in physics. The gradient... Actually, I think it's equal to negative u. Yeah, sorry. This is equal to negative force. Yeah. So wait, this might be a negative as well. I gotta remember where that comes from. Let me see, one sec. Forget if it's negative. Where is it? Where's the math? Okay, there you go. Okay. Okay, they just have it as F. Oh, okay, I remember how this works. In physics, it's negative because the potential is related with, like, the opposite of the force it takes to get there. Right. So, in the sense of gravitational potential energy, you build potential by fighting the force of gravity trying to keep it down. And that's why you put a negative on it. Because the force is technically down, but you fight that to create positive potential. And so that's why grad potential is equal to negative F. In this case, I think you just do this. So if we want to write this out, this is now, this is gradient, which is a vector. So I have d phi dx in the x hat direction, d phi dy in the y hat direction, and then d phi dz in the z hat direction. Nice. Has to be equal to u1 comma u2 comma u3. This pulls out a vector, and then component by component has to match. Okay, so this is cool. So you end up getting that, so d phi dx is equal to u1. And u1 was equal to y squared z, right? Okay, so that was equal to y squared z. So here's a cool thing. Yeah, I love this. This is actually really cool. If you move this over, and then just, I don't know, don't really worry about the partials. This is y squared z partial x. You can integrate both sides, okay? So this will tell you that phi must be equal to x y squared z, right? When I do this, plus some other function, which we can call this g, some function of y and z, right? Because look, if I take d dx of both sides again, this gets me the y squared z, and if this is only a function of y and z, d dx of this would be 0. So, yeah, that's part one. You kind of just do this for all three, and then you look for, like, what's the thing in common. So, d phi y must be equal to u2, which u2 is equal to... I remember, this is actually a cool part. I used to really slip on this, but after teaching it for so long, I've kind of become a lot more comfortable with this. Okay, so d phi is going to be equal to negative z squared sine y plus 2xyz. And then that's all dy. So then you can integrate both sides, all right? So then you get phi is equal to, so with respect to y, integral of sine y is negative cosine. So this becomes z squared cosine y, and then this becomes plus x y squared z, right? Because then divide by 2, 2 cancels out. And then this is plus something. You can say a function h that is of x and z. Because again, we integrated with respect to y. So if I take the derivative with respect to y on both sides, I'll get back what I wanted. And then this thing would go to 0 because it doesn't have y's in it. It only depends on x and z. Okay. Almost there. So then d phi dy is equal to u3. Technically, you can have this done with the first two. I like doing just all three because it's cool. It just looks fun. And then to me, it's really just recognizing a pattern. So that's equal to this. Okay. So then d phi is equal to 2z cosine y plus y squared x. And then that's going to be all dy. Integrate, integrate. You're going to get that phi is equal to 2z cosine y. Oh, sorry, this is dz. I fucked up. Sorry, I was getting ahead of myself. This is dz. Okay. This ends up becoming, oh, cool, just z squared cosine y. And then plus x y squared z. And then it's plus some function, I don't know, let's say k. That is a function of x and y. All right, great. So now we just like kind of compare all these because I need some super function that fits this pattern. So let's see what we can fit between them. All right. Something I notice in common, right, is there's always an x y squared z, x y squared z, x y squared z. So that shows up everywhere. So I know phi is equal to x y squared z at least. Okay. Plus, let's see if there's something else that shows up. Oh, there is this. Look, z squared cosine y, z squared cosine y. And then from that, right? It technically doesn't show up here, but that's because it is something that's just a function of y and z. So then you can say, oh, very cool, nice. So then plus z squared cosine y, and then you're done. So there you go. That's the potential function. And you can always check back, right? So if I take the derivative of this with respect to x, I should just get u1. Which I do, right? With respect to x here, I get y squared z plus 0. And that's what I wanted, right? Just y squared z. If I take the derivative with respect to y, I'm going to get what I want. And if I take the derivative with respect to z, I get what I want. Yeah, so super cool. All right, nice. Okay. And then here's part C. This is called the fundamental theorem of calculus, I think, for multivariable stuff. What is this? This is part C. This is a cool question here. Okay. Yeah. So it says find the value of the line integral. So you want to find the line integral. We could say like across a curve of u dt. Okay. For these values. Okay, and it says from 0, so from t's t's from 0 to 1. So we're gonna say from like t equals 0 to t equals 1. Yeah. This is where I need to make sure I don't fuck up. Because I also know from here, right, that u is equal to grad phi, right? I know that u is equal to grad phi. So if I plug that in, right, now we have the path integral from t equals 0 to t, the line integral, t equals 1, of gradient of phi dot gradient phi of t, I guess, right? Dot dt. And I believe, because you're taking the integral of a derivative, this is basically a super derivative. It's just a derivative in a bunch of different directions. Remember from before, right? If you have a to b of f prime of x dx, this is the same thing as f of b minus f of a. This is what we call like the fundamental theorem of calculus. But you're doing it here in like 3D land. So I believe this is the same thing as phi at t equals 1 minus phi at t equals 0. I forget with this if that's okay. I forget if you have to like chain rule this. I don't think so. So I think here's what you can say, like, so x of 0 in this case would be equal to sine of 0, so that's 0. Y of 0 would be equal to 0. Z of 0 is equal to 0. And then you can say like x of 1. So that's sine of pi over 2, so that's 1. X of 2 is equal to also 0. 1 minus 1, right? Then x, and then, sorry, not x of 2. Sorry. Y of 1 is what I meant to say, is equal to 0. Z of 1 is equal to just 1. Okay. So phi at t equals 1 is the same thing as phi of 1 comma 0 comma 1. And then I think this is phi of 0 comma 0 comma 0. Let's remember what we had for our expression for phi. So remember. So if you plug that in, well, this goes to 0, right? So that's 0 plus... Oh, cosine of 0 is 1. So this is 0 plus 1. So that's this one. Yeah, you just kind of like plug it all in, right? This goes in here. Goes in here. This goes in here. Which also goes into there. Whatever goes in there. So this is 0 plus 1, which is equal to 1. And then plugging in for 0... you just get 0 plus 0, so you get 0. So then it's 1 minus 0. I think the answer is just 1. I believe so. Let's go ask chat real quick. Was this question? Solve. Oh, man. It's probably gonna do some like PQR stuff I don't really care about. Yeah, whatever. Compute the curl. Come on, chat. You can do this quicker. There you go. Yeah, whatever. Cool. Find the potential. Yep. Yep, that's what we got for the potential. 0, 1. Answer's 1. Nice. Cool. We did it. Good question there. That was from Ayums. I think so, right? Yeah, it was a fun little vector calc question. Vector calc. Okay, let's see. Ethan, let me do yours real quick because you're here. Are you in the chat? You ready? Then I'll do you, Jossie. he's not here? Let me see. What else we got? Let's see this. I know Big C submitted. I do want to help Big C. Okay. Here. We'll get it. Particle at position R is rotating with velocity v is subject to the force directed towards the origin. Show that the angular momentum vector h equals mr cross v is constant. Well, oh, okay. Do they want like dh dt then, right? Wait, this is as a function of r. Okay, so f equals negative f of r vector. This is f vector. Angular momentum. Yeah, so a central force. I know L is equal to R cross omega, right? And then omega is equal to Is this true? I think this is true, right? So that's equal to R cross with respect to time. Okay. You have to see if it's constant, I guess, yeah. Oh no, sorry. R omega is equal to V. That's what I meant to say. Oh, okay. So what, like that? That's true, technically? Oh, wait, no. L is equal to I omega. That's what I meant to say. Yeah, okay. And then for a point mass, this is what I meant to say, sorry. And so for a point mass, yeah, sorry, force is equal to, yeah, R that's meh. Where does I point again? One sec. I need the vector form of this. Oh, it's R cross P. Ah, this is what okay, sorry. I just needed a refresher over angular momentum. I was kind of close. That's what I wanted, yes. L is equal to R cross P. But then V is equal to R omega. So L is equal to I omega. And then... Right. Okay. Yes. Okay. Cool. I understand all that. Great. So if it's independent... So we want to show if dH dt is equal to 0 then? So that's gonna be a product rule. V only, R omega if R is constant. Correct. So that's okay. DDT of M R vector cross V vector, yeah. But is R constant? Yeah, R is not constant. But wait. dr dt, is that not equal to v? Or it is, right? Okay. And then, sorry, is dv dt then equal to a? Which is equal to f vector over m? Okay. So I can pull the m out, right? All right. So what are we at? But here's my question: Do I need to do a product rule here? Because I'm taking the derivative of a product. So technically, I think it is. Yeah. Okay. Okay. So, but okay, this is a product rule. Product rule. So, we can pull the m out. So it's m dr vector dt cross v plus r vector cross dv dt. Yeah. And then I want to show that this is okay. Okay. We want to show this is equal to 0. So dv dt is equal to a. This is equal to v. So we have m v vector cross v vector. Well, wait a minute. Vectors crossed within themselves are 0.
Oh shit, not good.
Right? So this is 0. And then this is plus r cross a vector. But a vector is equal to f vector over m, which is equal to, f as a vector is negative fr r vector over m. Oh, this is really cool. So this comes inside. And then you get r vector cross. These are not vectors, so I can pull them out. So I can say negative f of r m. And then this is cross r vector, which is also equal to 0. Okay, cool. So 0 equals m. 0 plus 0. Cool, equals 0. QED. Nice. Cool. That was a cool one. You didn't really need any of this, actually. Right? I don't think we really needed this. Yeah, you don't need this. I was just trying to rederive it. You don't actually need any of this. You can actually just go from here. This is the important stuff. Remembering that the time derivative of a position vector is a velocity vector, and the time derivative of a velocity vector is an acceleration vector. Very cool. Okay, that was Jawsy. All right, Big C, you're up. Big C. Ooh, okay. It's a fun little one. Fascinating. Okay, secant squared over tangent squared plus 3 tangent t plus 2. This looks like a quadratic to me.
Good job.
Right? Doesn't this look like a quadratic? Yeah. This to me like screams quadratic. Where I think I would say like u is equal to tangent of t. So then u squared equals tangent squared t. Also, some other cool things here is that du. So derivative of tangent that would be secant squared t dt. Oh, that's actually beautiful. Yeah, because look, that thing, big C, shows up at the same place. This is actually a very pretty one. Okay, so this is the integral of du, right? Because secant squared t dt is just that. And then this becomes u squared plus 3u plus 2. So you can factor. And you get the integral of du over, this is going to be u plus 1, u plus 2. So now we got to do partial fractions. So I'm going to say 1 over u plus 1, u plus 2 is equal to a over u plus 1 plus b over u plus 2. So then u plus 2, u plus 1 is equal to a u plus 2 plus b u plus 1. Cool. I think that's how you do this. Well, actually, no. Sorry. This is just 1. Sorry, I got this wrong. This is just 1. Yeah, you multiply this whole side by u1 plus u2. Or basically you cross multiply. Okay, so then 1 is equal to au plus 2a plus bu plus b. So then a plus b u plus 2a plus b, like u to the 0, basically. And then this is equal to 0 u to the 1 plus 1 u to the 0. And then you match by terms. So I need nothing to equal everything that's in front of the u1. Right, so that tells me a plus b is equal to 0. And then here, 1 is in front of u to the 0. What else is in front of u to the 0? 2a plus b. So 2a plus b is equal to 1. Now you solve this. Solve. I would subtract them from each other, right? So you get that a is equal to 1. B is equal to negative 1. Nice. Okay, so now you have the integral of 1 over u plus 1 du plus the integral of negative 1 over u plus 2 du. These are very easy integrals. These are ln. So this is ln of u plus 1 minus ln of u plus 2, which you can combine ln's, right? So now that's ln and technically plus c. Don't forget c. So this is ln of u plus 1 over u plus 2. And then remember that u is equal to tangent of t. So you get ln of tangent of t plus 1 over tangent of t plus 2 plus c. And there you go, big C. That's how you do it. Cool.
Well done! Well done!
Big C. Nice question, Big C. That's a fun one. There's actually a lot of cool stuff in that. That's a great example of a chemistry, not a chemistry, sorry, of a calculus, like test question, because not only did you have u sub, You then also had partial fractions. And then, you know, some ln derivatives in there. Okay. Alright, let me see. Because I got 8 minutes left. You use proof by contradiction. Oh, this is cool.
Nice.
Thanks for the follow, Cloudy Day.
Good job.
I'm cheating on my exam right now. Oh, this is easy. We've done this. This is just this is super easy actually. Right? We've done this one. This is just r d theta. And then it's just e to the minus r squared. Yeah, I feel like that's an easy one to do. Ethan, are you around? Ethan. Want to help with this one, Ethan? This one looks fun. I got 7 minutes, Ethan. I'm gonna tag you. This one I know is super easy. One second, let me just like show this real quick. What's up, Leckle? This one's easy. So okay, so for polar, ds, which was equal to dx dy, goes to r dr d theta, and then entire plane used to be, right, for x, that was like negative infinity to infinity. That becomes r goes from 0 to infinity, and then theta goes from 0 to 2 pi. Okay. And then also x squared plus y squared is equal to r squared. So your new integral over the whole xy plane is now going to go from 0 to 2 pi and from 0 to infinity in terms of dr and d theta. And then the new vector, the new ds here is r dr d theta instead of just dx dy. And then this becomes e to the minus r squared. And this is a beautiful integral to do, because this is just u sub. You just say u is equal to negative r squared. Du is equal to negative 2r dr. Or that dr, right? So dr is equal to negative 1/2, negative 1 over 2r du. Or, wait, sorry. R dr, which is what I have, is just then equal to negative 1/2 du. Okay, perfect. So then we have this. We have a negative 1/2 out front. Then we have e to the u du. Let me think. Maybe I don't want... Oh, but okay. There's going to be new bounds on this. So integral of e to the u du is just e to the u. So that's going to be negative 1/2. And then that's going to be e to the negative r squared. From 0 to infinity. Gladiator says, I have a test on Wednesday, but technically we didn't learn derivative rules, even though some people already know them, so we have to go through first principles. That's so annoying. Yeah, you have to do the, what is it? The quotient difference thing. Okay, this is easy then. And then, sorry, and then there's still a d theta here. This becomes negative 1/2, and then this is 0 to 2 pi. And it's e to the negative infinity minus e to the 0. This is 0. This is just 1. So then you have 1/2 integral from 0 to 2 pi of d theta. And that just is going to equal to 2 pi times, so that's just 1/2 times 2 pi, which is just equal to pi. And there you go. You're done. Nice. What type of math is this? I'd say second semester calculus.
Well done.
Second semester.
Well done.
No quantum yet, Leckle. Okay. Oh, okay. You post it here. I'll do yours, Gladiator. It's always good to post it in the queue so I can see it. I see it. You posted it in the thing though. But we do have 2 minutes left, so I think I can do it. Let me post. All right, let's see. I just finished Calc 3 last semester. Next semester, I got OD in Physics 2. What do you recommend I pre-study? I'm in a co-op as of now. Are you a professor? Yes. I teach physics at UCLA. Physics 2? Is that going to be like E&M physics? ODEs is intense. You don't need to know ODEs for Physics 2. Oh, you're okay. No, I appreciate it, Gladiator. You're fine. I'll do yours. Gotcha. Thank you. I'm barely taking trig in college, but I just discovered my love for math. When my friend suggested I do electrical engineering over comp sci, I'm happy. Yes. Math is great. And yeah, honestly, comp sci degrees are kind of like going down the shitter these days. Because of all the AI stuff. I think Elon had it pretty well. I mean, he's right sometimes. He said, him and even the NVIDIA guy, Jensen, were like, go get a physics degree. Because you learn how to like solve problems. It's cool. And like math is dope. Electrical engineering is great. Yes, cloudy day. I think you're good for Physics 2. Pre-studying, maybe some vector stuff. I would study like cross products and stuff. Some of the integrals, like the Biot-Savart law, involves like a cross product integral, which can be kind of tricky sometimes, but it's not too terrible. Okay. Determine all points on this whose tangent line passes through this. And wait, I can't use derivatives? This is actually quite tricky. Oh, it's fine? Okay. All right, fine. Okay, so tangent line is y is equal to right, mx plus b, where the slope here is going to be like f prime at some position x. Right? And then figuring out what b is. So this is interesting. So let's see how this works. I remember this being kind of tricky. Okay, because 2x squared plus 3 looks like this, right? This is like 2x squared plus 3. But then all the tangent lines, right? These are like all the different tangent lines. And you want to know which of those tangent lines passes through the point 2, 7. So let's say, I don't know, let's pretend this is like 2, 7. So 2, 7 has to be a solution to the tangent line. Okay, so, okay. But here's the cool thing is, so for a tangent line, the slope of the tangent line is at least the derivative of the function at x. But then b depends on the point. So think about when you solve for a tangent line, right? You get the derivative, and then you plug in the solution. Then you plug in an x and y point along your line to then figure out b. Does that kind of make sense how that works? So to find the tangent line, let's say if I wanted to find the tangent line, and let me put this in a different color, right? Let's say like, okay, cool. All right, so y is equal to mx plus b, where m is equal to f prime of x. And then I think we have to come up like with an expression for what this is. So to solve for b, you need a point on the function, which would be x comma f of x. Okay. So in that case, you would get f of x is equal to m, so that's f prime of x, times x plus b. Okay, so b sorry, let me put this in. Do you always go live talking about math? Oh, awesome. Yeah, no, we do all sorts of things. We do physics, we do math, we do chemistry, we do stats. So yeah, I'm glad you found us. The website, I don't know if you'd used it already to like submit a question, but if you go to the website, actualofficehours.com, right here, there's a link here for the streaming schedule, and this will show you all the times that we go live. So usually we would have a stream tomorrow, but tomorrow's a holiday and I gotta go take care of some stuff, so not streaming tomorrow. Although Zach is another math streamer, he'll be doing stuff. But then our next stream will be Tuesday from 6 to 9. And then we have another stream on Thursday. Yeah, so this has the most up-to-date calendar of all the different streams that happen. And also you can join our Discord, which is cool. We have a big community, about like 2,100 people in it that we all like chop it up with math stuff. It's pretty fun. Okay, so in this case, B. Perfect. I'll be on the lookout for you guys. I love how interactive you are, brother. Keep it up. Thank you. Very welcome, dude. What FMA test comes out can you do a live solve? Oh. You mean when your exam? What's FMA? I don't know what FMA is. If you're asking, can I do your exam, then please don't.
Bruh.
I don't want to, like, directly help you with cheating. Oh, when a force exam comes out. Okay, yeah. If you want help with how to learn how to do it, I can totally help you. But doing people's exams, like, yeah. No, it's not going to help you in the long term. It'll help you get, like, one question right or one test right, but then you get screwed on the others. Okay. Okay, so B is equal to that. So, our full thing, right, is Y is equal to F prime of X times X. This is actually really interesting. And then plus B. then plus f of x minus f prime of x times x. Oh, that doesn't help us out. Oh man, I just get y equals f of x. No. Oh man, I remember this question is tricky. Fuck. I just get a equals a. Damn. Yeah, this is a wolf dressed in sheep's clothing. It looks like it's an easy question because I'm like, oh cool, I know what the equation of a tangent line is, and I can figure that out. And then, but then b depends, right, on where you are along the line. And then you needed to solve y equals 7, x equals 2. Oh, wait. No. Yeah, but these are different. Sorry. This, yes. No, here you go. This is it. This is 7. This is 2. Yes, now I remember. R prime t equals that was I taught in Calc 3. What iPad and not taking do you use? Oh, I just use a Wacom tablet. It's not even an iPad. It's just a little stencil thing. Yeah, have a great day. Yeah, I could do and solve it. I could solve some of it. I don't know if I would have time to solve all the questions because we get quite a few questions during the streams. Yeah, okay, so the key thing here, this is 7 and 2, right? But then this will also be 2. Oh shit. No. Yeah, I think I remember how this works. Okay. Can't we say the slope between the 2 points 2, 7, e and x, 2x squared plus 3? You could write all the tangent lines and solve? That's so many tangent lines. Sure. Yeah, we could say this. Okay, so slope. And I think we're getting basically the same thing. Yeah, and 2, 7. That has to be equal to the slope of the tangent line. That's actually a smarter way to write about it. Yeah. Yeah, I teach physics at UCLA. That's where I teach. Slope of a tangent line. Okay, so it's y minus y, right? So 7 minus 2x squared minus 3 all over 2 minus x. And then this has to be equal to f prime of x. Uh, 4x? Yeah, equal to 4x, yeah. Okay. Okay, cool. So, 7 minus 2x squared minus 3. So that's 4 minus 2x squared is equal to 8x minus 4x squared. Right? Oh, this isn't so bad. 2x squared plus 8x minus 4 equals 0. Negative 2x squared, sorry. Cool. Divide by negative 2. X squared minus 4x plus 2 equals 0. Yep, great. So, what is that? Is that solvable? X equals negative b. So 4 plus or minus 2 root 2 over 2. Okay, cool. So 2 plus or minus root 2. Yeah? I think I did it. Yeah, I'll call it. Good. Wait, check my answer? Oh, you want me to plug it back in?
Well done.
I think it's okay. Can I just trust it's okay? Did I fuck up somewhere, Jeff? Oh, just be pedantic. Okay, I'm just gonna. I have to go. I'm already late, unfortunately. But cool. All good, Gladiator. I'm glad you asked that question. That was fun. I wanted to help Ethan out, but Ethan kind of left, so I don't know what happened to Ethan. Okay. All right, cool. Let's close out the stream. All right, thank you everyone for coming to Actual Education Office Hours today. Appreciate all of you guys' suggestions, help, questions. Awesome. It was a fun Sunday. Our next stream, no stream tomorrow because it's a holiday. Go celebrate things, have the time off, enjoy. But we'll be back on Tuesday. So, but stay tuned on the Discord. I'll make some announcements about things happening this week.
I didn't even realize how my name was.
Oh yeah, I pinged you a couple times, Ethan. Sorry, I have to go now. I was trying to help you.
Yeah, I know. I'm in trouble.
It's okay. Yeah, come by on Tuesday. Yeah, nice to meet you, Visible Shift. Yeah, come by Tuesday. We'll help you out. If you're not following us on Twitch, go follow us on Twitch. It's awesome. There's a nice horizontal format. It's cool to see things. Let's see. Who we're going to go raid? Who have I not raided in a while? God of War X Science. That's kind of cool. Wait, what is Science doing? How did the ancients approach the scientific method? Whatever, let's just start it. Go say hi to Science. They're cool. They're one of the biggest science streamers out there, so say hello to them. Enjoy the rest of your weekend. Enjoy the holiday tomorrow. We'll see you on Tuesday. Peace.
Well, let's see. Actual education. Raiders, welcome on in. Actual education, how was your show? What were y'all up to today? I assume it was some mathematicallys, possibly, potentially, maybe.
Science stream, but we ain't fucking. We over here bubbling. You ain't shocking what we got.
Usually mathematicallys.
I promise that I have prescribed you vibes. The vibes we got are giant. Step into the stream for the raid. That's science.
Raiders, welcome on in. How was the stream? Tell me all the things. Guys, if you're not checking out Actual Education, does mathematicallys.